The University of Manitoba campuses
are located on the original lands
of Anishinaabe,
Cree,
Ojibwe,
Dakota,
and Dene peoples,
and the homeland of the Métis Nation.
We respect the treaties that were made on these territories.
We acknowledge the harms and mistakes of the past.
And we dedicate ourselves to move forward
in partnership with Indigenous communities,
in a spirit of reconciliation
and collaboration.
Hello, I'm Dr. Michael Benrush, President and Vice Chancellor of the University of Manitoba. It's my pleasure to welcome you to our online celebration of the research and scholarly leaders receiving the 2019 Winnipeg Rh Institute Foundation Awards. This year's celebration is taking place in this revised format due to the global pandemic. As the province's only research-intensive university, the University of Manitoba provides a dynamic environment for researchers to seek answers that ultimately benefit society, our communities, and ourselves. The work conducted by our researchers saves lives and leads to economic opportunity. It drives public debate on issues of global importance. While the home of this research is Manitoba, its impact is truly global. The RH Awards provide an opportunity to recognize this outstanding work and showcase our groundbreaking contributions. These awards are made possible thanks to the Winnipeg Rh Institute Foundation and the discoveries made decades ago by Dr. John M. Bowman. Dr. Cooper will tell you more about the work of Dr. Bowman and the foundation upon which these awards were built. Before I turn things over to Dr. Cooper and Dr. Jayas, let me extend my congratulations to our award winners. May the success you've nurtured lead you to bigger achievements in the years to come. Thank you.
Hello, I'm Dr. Juliet Cooper, Chair of the Winnipeg Rh Institute Foundation. I'm very pleased to be here today to celebrate this year's recipients of the Winnipeg Rh Institute Foundation Awards. These awards are given in two categories. One, recognizing the outstanding research accomplishments of an established University of Manitoba faculty member, the Dr. John M. Bowman Memorial Winnipeg Rh Institute Foundation Award. This award was originally established in 1997 and renamed in memory of Dr. Bowman in 2005. Dr. Bowman was an outstanding researcher and dedicated pediatrician who devoted his life to fighting Rh disease in the newborn. His groundbreaking work with Dr. Bruce Chown in the 1960s led to the development of an antibody to prevent Rh disease and the establishment of the Rh Institute in Winnipeg. In identifying the award recipient, both the quality and the impact of the research, as well as the distinction brought to the University of Manitoba by that research, are considered. In receiving this award, this year's recipient, Dr. Aniruddha Gole, is joining a truly special group of past honorees who have received wide acclaim for their achievements in Canada and around the world, and one in which he most certainly belongs. The second award, the Terry G. Faulkner Memorial Winnipeg Rh Institute Foundation Emerging Researcher Award, is given in disciplinary categories to academic staff members who are in the early stages of their careers and who display exceptional innovation, leadership, and promise in their respective fields. These awards were originally established in 1973 and were renamed in memory of longtime Rh board chair, colleague, and friend, Terry Faulkner. All the awards are made possible through funds set aside from the sale and production of medical formulae. On behalf of the Winnipeg Rh Institute Foundation, I congratulate all of our recipients and look forward to hearing exciting things about their research accomplishments in the future. Thank you.
Thank you for joining us for this celebration of the 2019 RH Institute Award winners. They are an exemplary group of individuals. I will begin by announcing each of the Terry G. Faulkner Emerging Researcher Award recipients one by one. Their slide will appear with a photo with their certificate and then a brief video message from each of them about their research will follow. In the applied sciences, Dr. Gozun Zhu, Mechanical Engineering, Price Faculty of Engineering, Canada Research Chair in Mechanical and Functional Design of Nanostructured Materials.
I'm Guozhen. My research aims to discover superior nanostructured materials by characterizing and tailoring nanoscale constituents embedded in the bulk crystalline materials. For example, functional oxide, light-weighted alloy, among others. I strive to design new nanoscale constituents confined at crystalline defect and to study their atomic and electronic structures based on high-resolution electron microscope. I'm also tracking the structure evolutions of these nanoscale constituents and the corresponding materials behavior using in situ techniques. My findings will guide the design of advanced materials, such as light-weighted alloy and functional composite, for the aerospace, automotive, and energy industry. I'm truly honored to be placed in such distinguished rank. Special thanks goes to Dr. Cohen for his nomination, Dr. Oliver, Dr. Wang, and Dr. Shen for their recommendation, and the World Committee to put their faith in me. I sincerely thank my research team at U of M and my past team at SJTU, Yu Shun, Minghui, Fang, Dongyue, and many others. Without you, there's no such beautiful work. I'm also grateful for enormous help and support from my collaborators and friends inside and outside the university. Like past honorees, I will certainly do my best to meet the expectation of this award.
In the health sciences, Dr. Kelly Thiessen, College of Nursing, Rh Faculty of Health Sciences, Scientists, Children's Hospital Research Institute of Manitoba.
Hi, I'm Kelly Thiessen. I'm a midwife, clinician scientist whose clinical practice focuses on building interprofessional practice and research in maternity care settings. This program generates an evidence base to inform health policy and health service delivery in how to best utilize midwives and other health professionals while also optimizing patient and system-level outcomes. There's been a long-standing need in Manitoba and Canada to expand and optimize midwifery in our health system. In my research program, our team seeks to identify and describe exemplar maternity service delivery models that are integrated, cost-efficient, culturally appropriate, and ultimately effective in supporting persons to maintain health and wellness in their own community. Through community collaborations across the North and beyond, our hope is to support communities to address necessary change to improve access to community-based maternity services to meet population health needs within the community.
Also in the health sciences, Dr. Frederick Zeiler, Surgery, Max Rady College of Medicine, Rady Faculty of Health Sciences.
My name is Fred Zeiler. I'm one of the neurosurgeons in Winnipeg. I'm a clinician scientist whose clinical practice focuses on the management of cranial neurotrauma, with my research program in Winnipeg focused on the application of multimodal invasive and non-invasive cranial physiologic monitoring. This program integrates complex, high-frequency signal processing with neuroimaging, protein, and genetic biomarkers with the goal of uncovering the molecular mechanisms involved in impaired cerebral vascular activity in traumatic brain injury. This would allow for the development of potential treatments directed at prevention and treatment of vascular dysfunction and traumatic brain injury. I'm honored to have been selected for the Terry G. Faulkner Emerging Researcher Award, and would like to thank the Rh Institute Foundation for their support. As one of the only surgeons in the history of the award, it highlights the major recent strides made by the Rady Faculty of Health Sciences and the Department of Surgery in supporting surgeon scientists at the university, advancing surgical research for the betterment of Manitobans and Canadians.
In the humanities, Dr. Jonathan Payton, Environment and Geography, Clayton H. Riddell, Faculty of Environment, Earth and Resources.
I'm Jonathan Payton. As a human geographer, I focus on the social, economic, and environmental effects of post-war energy, mining, and infrastructure development megaprojects. My current research is on the initial stages of offshore oil and gas development in the Canadian Arctic, focusing on the relationships between extraction and conservation spaces, scientific research and knowledge claims, and Indigenous activism and corporate industrial dreams. I'm delighted to accept this award, and it gives me a great opportunity to thank my colleagues in the Department of Environment and Geography, my fellow travelers in the Critical Environments Research Group, and especially a wonderful group of graduate students who've always helped to push my research on resource conflict in new and promising directions.
In the interdisciplinary category, Dr. Ping Zhao Hu, Biochemistry and Medical Genetics, Max Ready College of Medicine, Computer Science, Faculty of Science, Electrical and Computer Engineering, Price Faculty of Engineering.
I'm Dr. Ping Zhao Hu. I'm an associate professor in the Department of Biochemistry and Medical Genetics. I conduct research on developing and applying artificial intelligence and statistics technique for integrated analysis of complex health data for precision medicine. My research program is the interface among computer science, statistics, and genome science. My most current research interest is in developing flexible and robust deep learning model for radiogenomics and drug discovery. Thanks for the RH Award. It's my great honor to receive it. I would like to thank everyone, including my mentor, colleagues, and my dedicated student, who has supported my interdisciplinary research program over the past 6 years. It would be impossible to achieve this without their great support and help.
In the natural sciences, Dr. Jacob Burgess, Physics and Astronomy, Faculty of Science.
My name is Dr. Jacob Burgess. In my laboratory, we design, build, and apply unique microscopes capable of making movies of atoms as they act together quantum mechanically, over times faster than a trillionth of a second and over distances less than a billionth of an inch. We are working to understand how atoms in complex materials influence each other and to gain insight into how to control the properties that emerge from their collective behavior. This knowledge will help pave the way for technologies impacting high-efficiency computing, encryption and privacy, solar energy, and lossless energy transmission. I would like to thank the Winnipeg Rh Institute Foundation for supporting my research with the Falconer Emerging Researcher Award. I would also like to thank my colleagues in the Department of Physics and Astronomy at the University of Manitoba for their crucial support in building my research program.
In the social sciences, Dr. Will Oxford, Linguistics, Faculty of Arts.
I'm Will Oxford. My research focuses on the structure of words and sentences in the Algonquian languages, which is a language family that includes Ojibwe and Cree spoken here on Treaty 1 territory. I work with speakers of these languages to document their grammatical structures and to understand what deeper lessons these structures can teach us about what's possible in human language. I'm currently working on a web database that brings together existing research on these languages and presents it in an accessible way. And I'm really grateful to the RH Foundation for the Falconer Award, which will help to support this project.
Now to our next award recipient, the Dr. John M. Bowman Rh Institute Foundation Award. The recipient is Distinguished Professor Dr. Anirudh Gole, Professor Electrical and Computer Engineering, Price Faculty of Engineering, and Industrial Research Chair in Power System Simulation. Dr. Gole is a Fellow of the IEEE, a Fellow of the Canadian Academy of Engineering, and a registered professional engineer in the province of Manitoba. Dr. Gole completed his undergraduate education in electrical engineering at the IIT Bombay, India, in 1978, and his PhD from the University of Manitoba in 1982. He has worked on various aspects of DC transmission at Hydro-Quebec and Manitoba Hydro. His research areas include power system simulation and power electronic applications in power systems. He has developed efficient methods for the control of capacitor-commuted HVDC converters and was the first to develop a complete and accurate modeling approach for the control of large power electronics-based transmission systems. Between 1980 and 1985, he worked with Dennis Woodford and Garth Irwin at Manitoba Hydro to develop the world's first simulation program for networks with power electronic converters. This program now has over 35,000 users worldwide. He later contributed to the development of world's first real-time digital simulator, RTDS, for power systems manufactured by RTDS Technology, Inc. of Winnipeg, which is located on the Fort Garry campus in a smart park, our research and technology park. Together, these products have been used for design and operational studies of over 80% of the world's high-voltage DC systems. Recently, Dr. Golay and his students constructed a high-speed model for recently introduced modular multi-level converters, MMCs, used in HVDC transmission. His modeling approach has been universally accepted and is now used by all the major simulator vendors worldwide. In addition to receiving the Bowman Rh Award, Dr. Golay has been recognized by the Institute of Electrical and Electronics Engineers with the PES Nari Hingorani Facts Medal. Congratulations on this well-deserved recognition, Dr. Golay.
Hello, everyone. I'm Ani Golay, and I'm a professor at the Department of Electrical and Computer Engineering at the University of Manitoba. And first of all, I would like to express my thanks to the Winnipeg Rh Institute Foundation for considering me as a potential candidate for the John Bowman Memorial Winnipeg Rh Institute Foundation Award. I feel honored to receive it, and I do so also on behalf of the large number of graduate students, postdoctoral fellows, and other research colleagues that have contributed to the research output of my team. Energy is an indispensable requirement for modern society, which has significantly increased our standard of living. The electric grid is an efficient transportation medium for this energy that enables it to be moved from one area to another without the requirement of any physical conveyance. Imagine shipping coal or oil over roads or railways, as was done not too long ago. The electrical network of today is also undergoing a great transformation. Gone are the days when electricity was generated close to population centers and essentially serviced only local loads. Today's networks are continent-wide, and there is even talk of connecting multiple continents together. Such an arrangement allows harnessing renewable energy sources such as wind, solar, or hydroelectric energy and transporting it to distant populated destinations. Of course, the significant amount of interconnections also requires the infrastructure to possess a very high degree of reliability and security, without which blackouts over vast geographic areas would result. The advent of power electronic converters employing solid-state switches, such as thyristors and insulated gate bipolar transistors, has enabled very precise control of the power flows across the grid. Indeed, the bipoles of Manitoba Hydro's high voltage direct current, or HVDC as we abbreviate it, system use such converters for conveying energy from the northern hydroelectric resources to the load centers in Winnipeg and other Canadian and US locations. They have had a significant impact on Manitoba's economy and on the First Nation citizens who now share in these hydro resources. The very complexity and size of the modern power grid makes its design and operation a great challenge. Experimentation is generally not possible as can be done with other industrial products. For this reason, the behavior of such large power grids is usually investigated using computer-based simulation tools. The Manitoba engineering community is a world leader in simulator development. Two of the world's leading manufacturers are based in Winnipeg. PSCAD EMTDC, which with a user base of over 35,000 international users, is now the world's most widely used electromagnetic simulation program for power systems. It was originally developed by Dennis Woodford at Manitoba Hydro, working with me and my erstwhile graduate student Garth Irwin at the University of Manitoba. The great increase in computing power available today means that real-time simulation is now a possibility. Real-time simulation produces results as fast as in the real world, and this permits the testing of control hardware while connecting it to a simulator instead of to the real system. A team of researchers from the Manitoba HVDC Research Center and my graduate students, Dr. Trevor McGuire and Rudy Weirix, developed the world's first and to date the most widely used real-time simulator, the RTDS, which is now commercialized by RTDS Technologies of Winnipeg. This happened in the late 1980s. In the last 2 decades, PSCAD and RTDS have been used for the design of the majority of the world's high-voltage DC transmission systems. Something about the research at the university. Research at the University of Manitoba has been and continues to be an indispensable component in maintaining the cutting edge of power system simulator research. One key recent contribution was a new mathematical technique that speeds up the simulation of very large converters, such as the multi-level modular converter, or NMC, by at least 2 orders of magnitude. Present research in our group concerns the development of robust and fast simulation algorithms for very large systems and the development of new control techniques for the power grid. We are also investigating the use of hybrid real-time simulation platforms, where multiple computer platforms, each running a specialized algorithm for modeling a specific component of the grid, can be interconnected to provide even greater simulation capability. Now, about how I intend to use the generous RH Award. I intend to use the award primarily for creating opportunities that enhance the professional development of my graduate students, such as the support of conference and field trip travel. Finally, in closing, I would once again like to thank the Winnipeg Rh Institute Foundation for the award, and together with my team, I promise that I will try the very best to continue our research in the highest traditions set by earlier award recipients and the award's namesake, Dr. John Bowman, one of the early co-founders of the RH Institute and an internationally recognized expert in the treatment of pediatric Rh disease. Thank you very much.
I offer my sincere congratulations to all of the award winners. I would also like to especially thank the members of the RH Award selection committees for their deliberations in selecting such fine candidates. Thank you for joining us for this celebration. Megwich, merci, thank you.